Good morning. Today we're going to go over Unit 4, Day 6 and Day 7 notes. Day 6 notes, we kind of already went over how to classify a triangle and what an isosceles and equilateral triangle is. We're just going to go over how to solve equations using this information. So the base angle theorem says if we have two sides of a triangle that are congruent, this side is congruent to this side, then the base angles are congruent. We know this. My opposite angles are also congruent. Okay, this and this. The converse is also true. Remember, converse means change order. If the base angles are congruent, then the two sides are also congruent. So this one, they're giving us that my angles are congruent, then I know my opposite sides are also going to be equal. And you guys can finish this. If AB is equal to AC, then angle B is equal to angle C. If we want to solve these, what we're going to do is we're going to really use the fact that the angles in a triangle add up to equal 180. So if this one is x, and these are my congruent sides, then my opposite angles are equal. So if this one is x, then this one is also x. And now I know that x plus 6 equals 180. I'm going to subtract 6. And we're going to combine my like terms. We have 2x equals 174, and then we're going to divide by 2. Wish I had you guys here. So when I divide by 2, this x equals 87. Okay, so this is 87 and this is 87. Alrighty, in this case we have these equal angles, and my opposite sides also have to be congruent. So the 17 is here to distract us. This is a distractor. This one is, so that means that 2x plus 1, this side, is equal to this side, which is 15. So I'm going to set them equal. Now you guys solve for x. Tell me what x equals. An equilateral triangle, a triangle is equilateral if it has 3 equal sides or angles. If a triangle is equilateral, meaning the sides are equal, then it is also equiangular, meaning the angles are equal. But if it's equiangular, then it's also equilateral. I want you to write this as a biconditional statement. Remember, biconditional means in the middle we will have if and only if. Try it out. These are my congruent sides. Let's try this problem. That means my opposite angles are equal. That means that this angle is equal to this angle. Oh, but this one's given, it's 54. That means this one is also 54. And then I'm going to use the fact that the angles in a triangle add up to equal 180. So 54 plus 54 plus x equals 180. You guys can solve for x. This one is a little bit more complicated. Let's try it out. If this side is equal to this side, remember my opposite angles are equal. But this one is 65, so this one is also 65. All right, I need to find this angle. Well, I'm going to add up 65 and 65 and subtract it from 180. 60 and 60 is 120, 5 and 5 is 10, so this is 130. 180 minus 130 is 50 degrees, so this is 50 right here. Remember, these are vertical angles, so this is also 50. Uh-oh, but I see that these sides are also equal, so my base angles are equal. So if this is 50, this one is also 50. And I know that these angles in the bottom triangle also equal 180. 50 and 50 is 100. 180 minus 100 is 80. So x is 80. That was quick. Try it by yourself and then retry it if that doesn't make sense. If that is difficult for you, you can look at what I did. Go ahead and go to Unit 4, Day 7 notes. We're going to go over overlapping triangles. It says how many triangles are in this diagram. That's what it says. How many triangles are in this diagram? Count them. Some of them are overlapping. It says separate and redraw a triangle ABD. ABD. Let me just draw it in red since I drew it in red. I'm going to highlight it in red. ABD. And then we go back to A. So I tried to redraw it right here. And then it says redraw DCA. DC. And then we go back to A. And I redrew it right here. It says, what is the common side? I didn't even have to redraw the triangles to see what the common side is. They both have A. And they both have D. So I know that AD and AD is going to be my common side. Separate and redraw the overlapping triangles. Identify any congruent parts of the two triangles. So it says GLK, which is this triangle. I'll do this one in red. GLK. You guys can redraw it, maybe over here. And HJL. HJL. Do we have any congruent parts? Nothing is completely overlapping, right? This little tiny side is not the whole side of blue. So these are not going to be overlapping or congruent triangles. I don't see anything that's congruent. Let's try this one. MRP. Oh, I see this one. And NQS. Ooh, these do look equal. But is there anything that's completely overlapping? This whole side isn't sharing anything. This whole side or this whole side. So I gotta say there's nothing congruent. You guys can separate them. FED and CDE. Let's try this one. FED and CDE. What side or angle are they sharing? It looks like they're sharing the side ED. I want you guys to try number 4. Let's try a proof. I always want you guys to separate the triangles if they're overlapping. It says that triangle AED, so this triangle, we're trying to prove that this triangle is congruent to CDE. So I will redraw them in black so that I can use my colors to label my congruent information. So this is A and E and D. And I'm trying to prove that it's congruent to CDE. Kind of like slants back. This is E and D and C. All right, this is what they give us. They say that A to B, this side, is congruent to C to B, this side. So this side is congruent to this side. Okay, I'm going to write it in here. AB is congruent to CB. And they give us AE, which is this side, is congruent to CD, which is this side. And they give us that angle AED, which is this angle, is congruent to angle CDE. Okay. This is all given. I'll write it down here. Angle AED is congruent to angle CDE, right? This is all given. This is given to me. This is information that is given to me. Now, these triangles are overlapping on a common side. Their common side is right here, and it is ED is congruent to ED. Remember, when we say anything is congruent to itself, this is always going to be the reflexive property. Okay, now I have 3 pieces of information, 1, 2, 3. That's all I need to prove my triangles are congruent. So I'm going to write it in there. Triangle AED is congruent to triangle CDE, because this is when I have to input one of those reasons. Either side, 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 angle, side, angle, side, angle, 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 side, or HL. This is going to be, remember we start where there's no congruencies and we can go clockwise or counterclockwise, side, angle, side. Or it could have gone the other way, side, angle, side. Let's try one more. It says angle PSR, so this whole S, and PQR are right angles. Prove that QPR and SRP are congruent. Okay, so I'm going to redraw these triangles separate. I'm going to redraw them. Always redraw your triangles if they're overlapping. This one, I think you can do without redrawing them, but I want you to get in the habit of it. And then the top one is, they say Q P R. Yeah. Okay. I'm gonna write in here what is given. Sorry, my computer was dying. I'm going to write in here what is given. It says angle PSR and PQ. I don't know what I did. Are right angles. And this is given. And I'm going to plug in that information. PSR is angle S. PQR is angle Q. Also, I'm going to write in here angle QPR is congruent to angle SRP. This is also given. Now I'm going to plug it into my diagram. QPR, this angle, is congruent to SRP, this angle. This is my given. We really should say that angle Q and angle S are congruent to one another. So I'm going to say this angle PSR is congruent to angle PQR. And my reason are all 90-degree angles are congruent. If this one is 90 and this one is 90, that means that they're congruent because they're right angles. Okay, and now I need one more thing. I have 2 pieces of information. I need a third, but do you guys see that they have a common side? PR is their common side. So I can say that PR, they're sharing this common side. PR is congruent to PR because of the reflexive property. And this is always going to be the reflexive property when they're sharing a common side. Now I have enough information to prove that triangle QPR is congruent to triangle SRP. Now I need to find out why. Is it side, 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 angle, side, angle, side, angle, 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 side, or HL. There are 5 of them. Let's look at our diagram. It looks like we went to an angle, the very next angle, the very next side. Angle, angle, side postulate. We could have done this. We could have gone this way, but it would have been side, angle, angle. You got to know that side, angle, angle is just angle, angle, side, but backwards. And we will only write it as angle, angle, side. All right, guys. If you have try the other ones, if there's another one, try it out. If you have any questions, let us know.